my talk this morning is called The Blessing of No, which I admit, something about myself, I'm not really a fan of being told no. That doesn't mean that some people, if they're not a fan of being told no, just persist until they get the yes that they want. I'm more likely the type that just won't ask if I think that the answer is likely to be no. So I either just go without or go by the saying that's easier to ask forgiveness than permission. But yet, at the same time, I realized one of my favorite Bible verses is actually an instance of God saying no. In 2 Corinthians 12, Paul speaking, he says, "So to keep me from becoming conceited, because of the surpassing greatness of the revelations, a thorn was given me in the flesh, a messenger of Satan to harass me, to keep me from becoming conceited. 3 times I pleaded with the Lord about this, that it should leave me. But he said to me, my grace is sufficient for you, for my power is made perfect in weakness. Therefore I will boast all the more gladly of my weakness, so that the power of Christ may rest upon me." And sometimes, as we see here, God says no for our own good. And we're supposed to be talking something about our field, which I wasn't sure which thing to talk on in the one sense, since I teach a smattering of classes. But I'm going back to what's actually quotes my area of expertise of what I did in grad school. But first, a demonstration. So if I can get 3 volunteers, all you have to be able to do is read to do this. So hopefully, if you've made it to college, anyone could help. Thank you. Thank you. And go ahead and grab mics. Now come on up. We have 2. Okay. Could you really quickly mute me so that I can give instructions just to the volunteers? Thank you. All right, so we're going to read just a short Bible passage here. Go for it.
You shall walk in all the ways which the Lord your God hath commanded you, that you may live.
All my commandments always,
that you may prolong your days in the land which you shall possess. Deuteronomy 5:39.
Right. So, God's word is a blessing, right? Or maybe we should try that again, but with some inhibition in here, where we'll start. Kevin.
Oh, that there were such a heart in them, that they would form me and keep all my commandments always, that it might be well with them and with their children forever. Deuteronomy chapter 5, verse 29.
Ye shall observe to do therefore as the Lord your God hath commanded you. Ye shall not turn aside to the right hand or to the left. Deuteronomy 5:32.
You shall walk in all the ways which the Lord your God hath commanded you, that ye may live, and that it may be well with you, and that ye may prolong your days in the land which ye shall possess. Deuteronomy 5:33.
All right. Thank you all for your help. Doesn't matter. You can either keep them or give it back. Either way. So you saw with this little demonstration, and I appreciate especially the enthusiasm that they gave to that initial reading. But it didn't make much sense the first time, because everything was just happening at one time. Everyone was talking together, and there was no order. Paul said in 1 Corinthians 14:4, let all things be done decently and in order, because they were having these problems with everyone speaking in tongues or prophesying, doing other things at the same time, and it gets chaotic. Now, our brain faces this same potential issue. So within the cortex, I'm just looking at the outermost layer of the brain, but a portion of the brain that is responsible for a lot of your cognition and senses that you enjoy, hopefully. And in this cortex, we see roughly 80% is excitatory. Those are the neurons that we tend to think about. They're the ones that are the go. They're telling you to do, and giving information on. But some 20% of the neurons are actually saying, stop, hold on. They're giving some inhibition. And they're sometimes thought, specifically this one class that I was studying, the largest grouping of these, at least in the cortex, are the parvalbumin expressing, or PV, inhibitory interneurons. Interneuron just means they're only going over short distances. They're not, so they're sort of local directors. The two most common analogies I hear for their role in the brain is either like a traffic cop. So if you think of, if you've ever been somewhere and the power went out and there's a stoplight normally there that no longer has power, initially people treat it as a four-way stop, but sometimes someone will come in and will sort of start directing traffic and telling who to go, who to stop, who to wait. Or the other one I've heard is an orchestra conductor that tells some instruments to play, some instruments to stop, some maybe to play more loudly, some to play less loudly, and just makes from just instead of a cacophony of noise, a more organized, meaningful passage of information. And a couple things that this made me think of. One, just the body of Christ and how this diversity is necessary. If all the cells were excitatory, it wouldn't work well. If all the cells were inhibitory, well, nothing would happen either. There's this importance of balance that Christ made into things. And in thinking about this, the inhibitory, it made me think of Christ's law, which at times may seem a little bit inhibitory. But at the same time, it can all be summed up, as Christ said in Mark 12, when he was asked, what's the greatest commandment? He said, the first of all the commandments is, Hear, O Israel, the Lord our God is one. And thou shalt love the Lord thy God with all thy heart, with all thy soul, with all thy mind, and with all thy strength. This is the first commandment. And the second is like, namely this, thou shalt love thy neighbor as thyself. There's none other commandment greater than these. So it can all be summed up in those two. Or typically, we may think of the 10 commandments. And we see that's not that high of a number. Similarly, in the cortex, roughly 10% of the neurons will be these PV neurons. Now, what I was studying with them was really what role they had to do with plasticity, so the ability of the brain to change. So what role do they play in that process? So I guess in one sense, something that Dr. Martin and I have in common is that we both have studied vision to some degree. Just mine started in the primary visual cortex. We sort of skipped over the eye and thalamus and some other parts along the way. And there's a few things with this plasticity that I'll point out. First being that there's certain times at which it's heightened. Some of you may be familiar, for instance, that there's certain ages at which it's a lot easier to learn a language or to learn certain other things. So these in neuroscience, we talk about critical periods. These critical periods, times at which development is more easily swayed one way or another. So it made me think Ecclesiastes 3:1, where he says, to everything there's a season, a time to every purpose under heaven. Then another thing I'll mention is this balance. Balance is very important in the brain. So one, we need a balance of this plasticity. So plasticity is a blessing. Who isn't thankful that you're able to learn new things? But at the same time, if your brain was overly plastic and only always learning new things, there's certain essential things that we have learned that we don't really want to forget. Sort of like that saying where they say, once you learn how to ride a bicycle, you just never forget. You may go for years, sometimes between childhood and then adulthood, but you can still hop on and you still have that motor muscle memory to remember how to ride the bicycle. At the same time, also, excitation and inhibition are important. If you get too much excitation, it's sort of like the example of all the students talking at the same time. This sometimes illustrates itself as things such as epilepsy. On the other hand, if you have too much inhibition, it's like when you're in class and the teacher asks a question and you just hear the crickets because nobody is responding. So you need this balance. Now, with the visual system, I'm going to go lightly into science, nothing too serious. The visual system is sort of a classic model for studying this plasticity, this ability to change. It first started being studied in cats. Thankfully, we've discovered that many of the same things hold true in mice. And it's a lot easier to do these things to mice than to cats. And in the visual system, so what's being illustrated here, we see this idea. Many of you may be familiar with the idea that the left eye is, a lot of the information from it is processed in the right hemisphere of your brain. And the right eye, a lot of it's processed in the left hemisphere. So you have this sort of this crossing over. And then there's also a region of that brain where, and this will vary from animal to animal as to what percentage is which. There's a region of the brain that receives inputs from both eyes. We as humans have a much larger region of the brain that's responding to both eyes than animals that have, for instance, their eyes more on the side of their head. So normally, what's called contralateral or opposite side eye is the primary driver of the neurons in the brain. So they'll be excited by the things that come from the opposite side, and lesser from the things that come from the same side. And this is looking just within that binocular zone, this zone that's driven by both eyes. However, if some sort of visual perturbation occurs, so for instance, you, in one way or another, stop the mouse from seeing through its dominant eye for just a short period of time, like 3 days, of what's called monocular deprivation. So they're only able to see through one eye. We see this shift occur, this plasticity occurring in what the driver of the neurons is. So now they're being driven more strongly by the same side eye than they initially were. And this is all looking at excitatory neurons. In inhibitory neurons, they lack this bias. But it had been discovered that the inhibitory neurons did seem to play some sort of role in this shift that's able to happen. But as some of you who've been in science may realize or have read anything for long, you start to see that even though one of these papers was published in the journal Science, one was published in Nature, both very prestigious high-end journals, they didn't agree with one another. So not both of them could be true. And they weren't sure as to what roles did these inhibitory neurons play in plasticity, and also just what happens when they are deprived of this stimuli, what happens to them. They seem to become more immature in some ways, but in which different ways. So I won't go into all that details, but I will briefly look at sort of the basic technique that was being used. we use something called 2-photon guide in vivo cell attached recordings. So breaking this down, so 2 photons, just the type of microscope. It's a microscope that allows you to see through relatively opaque tissues. So that was being used to be able to know where we were putting the pipette. In vivo just means in life, so the animal's alive. Some of the classic neuroscience removes the brain and then studies it, but we're studying it in a living animal. Cell attached is just, it's a electrophysiology technique where you're taking an electrode and you're just putting it up to the cell. So it's sort of like if you've ever put your ear up to a door, if maybe your parents are having a conversation in the next room and you're curious what they're saying, or like a doctor takes a stethoscope and puts it up and just listens to your heartbeat. It's sort of like that. So you're just listening in on the cell's activity, listening in on the transmission from that cell. Now this is it's advantageous and it's an improvement over the previous method, because previously pretty much what they would do is just keep sticking the pipette in time after time after time, and about 1 out of 10 you actually will get the type of cell you're looking for. Now these cells do have a unique signature in how they spike, in their communication is very fast. They have, so it's being shown on the right hand side of this little graph, is they have this very unique waveform to them that does allow you to differentiate them from the other cells. And they're very fast, so you have this very quick inhibition available. And they primarily will either act on the soma or cell body or on the axon initial segment. So they're there, the cells are gaining information from dozens, hundreds of dendrites, giving them information, and then they have to determine which of this information is actually relevant to pass on. And these cells help sort of sometimes determine that and sort of act as that orchestra conductor, so to speak, of these messages going around in the brain. And having this technique even made me think Psalm 119, 105, well-known passage, "Thy word is a lamp unto my feet and a light unto my path." So thankfully, God doesn't lead us just sort of blindly poking in the dark, which was the old technique that they used to have to use, but we're given this guidance. We're able to see and know where we are supposed to go. That's part of what this law that we've already mentioned is doing, is giving that guidance. And or also giving protection, because sometimes things that may seem inhibitive are also protective as well, as is illustrated if you've ever been to a zoo and seen, yes, the barrier is there and does stop you from being able to pet the nice giant cats, but it also stops them from having lunch. So in summary, I'm sort of skipping over all the actual research, how I went about doing it, but basically what we found is that these PV neurons were found to be permissive rather than instructive of plasticity, at least in this system. In some cases, I realized God sort of does both. He's both permissive, allows us, gives us that freedom of choice, but also thankfully gives us instruction. And found that in some ways these PV neurons, if deprived of this normal stimuli, they became seemingly less mature. In some ways, other ways they would hold on. And it makes me think of a few different passages, such as iron sharpens iron, or forsake not the assembling of yourselves together. There's something about having this proper stimuli, this proper input that helps keep us mature, keeps us growing, keeps us from reverting to these other states. Now, in going back, the initial title of the talk, I'd said the blessing of no. So if we think about this idea of inhibition, of saying no, our first parents, Adam and Eve, they failed to say no. And they gave in, and sin entered the world. And then Christ came on a rescue mission to rescue man, but also to vindicate the character of God, to vindicate that the law, if lived out perfectly, was a blessing. He said no to all these temptations that the devil threw at our parents, at us, the things that we fail to, he said no to. And he lived out this law perfectly, was protected from sin, provided us this ransom from sin. In first selected messages, it says, "No man of earth or angels of heaven could have paid the penalty for sin. Jesus was the only one who could save rebellious man. In him, divinity and humanity were combined. And this was what gave efficiency to the offering on Calvary's cross. At the cross, mercy and truth met together. Righteousness and peace kissed each other." So we see that he came. He doesn't leave us simply to perish, but offers us this reward, this what we do not deserve, such that the final blessing of no that we get is told us in Revelation 21:4, where it says, "He will wipe away every tear from their eyes, and death shall be no more. Neither shall there be mourning, nor crying, nor pain any more, for the former things have passed away."